Good afternoon, students. Today we'll try to learn some properties based on definite integrals. Then we'll try to solve numericals based on definite integrals. Okay. So now let us try. We have here that is definite integrals. To solve them, we need to learn some properties. Let us try. First property we have P0, that is we have an integrate AB fx dx a to b, then we got a to b ft dt. Okay, we take x is equal to t, we substitute. So by substitution we do this. Now we have next property, that is a to b limit fx dx. We can write minus a to b fx dx. Okay, but in some cases, in particular some cases, we can also say about a to a fx dx is equal to 0. Okay, likewise now we have the next property, that is a to b fx dx is equal to a to c fx dx plus c to b fx dx. Okay, so c may be somewhere in between a and b. So a to b, a to c, then c to b we have. Now we have the fourth property. Okay, now the fourth property is, that is a to b fx dx is equal to a to b f a plus b minus x. Okay, plus c minus x. So these are the four properties. Now we'll move to the fifth property, that is 0 to a fx dx is equal to 0 to a f a minus x dx. Okay, and if we can see that this property is a particular case of this only. Now we'll move to the fifth property, that is 0 to 2a fx dx. Then we'll have this 0 to a fx dx plus 0 to a fx dx. Okay, so this is the property we have. Now we'll move to the next property, f of dx. Here we will have f of 2a minus x dx. Likewise now we have the next property, that is 0 to 2a fx dx is equal to twice of 0 to a fx dx if we have f of 2a minus x is equal to fx, and if f of 2a minus x is equal to minus of fx. Okay, if I take 0 here, if this value becomes 0, then it means 2a minus fx. Okay, if it's positive, then you can take twice. Okay, so we have now last property, that is minus a to a fx dx is equal to twice of 0 to a fx dx. Okay, twice. If a is an even function. Okay, if a is an even function, and if f of minus x is equal to fx. Okay, in function, that is f is an even function that is just minus x will be x if it's an even function. Now in second case we have minus a to a fx dx is equal to 0 if f is an odd function. That is, if f of minus x is equal to minus of fx. Okay, so these are the 7 properties on which we'll solve the numericals for definite integral. So this is what they have given. Okay, so now we'll try to solve numericals so that we can easily, solve numericals on this. So these are the 7 basic properties. Okay, so now let us try to solve the numericals so that we easily understand how these properties works. Now we'll try to solve the numerical based on these properties. So now let us try. Okay, so now let's begin with, we have first question here, limit 0 to pi by 2, we have cos square x dx. Okay, so now we'll see, we can write cos square pi by 2 minus x. Okay, with respect to dx, 0 to pi by 2. So now I got 0 to pi by 2 sine square x dx. Okay, now we got, this one was I1 and this is now I got I2. Now I will be adding both. I will be adding both, that is I1 plus I2. So we got this sine square x plus cos square x dx, and limits we have 0 to pi by 2 is equal to 1, that is dx 0 to pi by 2, and we got x, that is pi by 2 0, so I got pi by 2. Now I plus I, this becomes 2i, so 2i is equal to this much. Now we'll put the value here, so we can write here also 2i is equal to this much, so therefore pi by 2, so therefore I is equal to pi by 4. Okay, here we have applied the identity, the property, that is, it will be fx. Okay, is 0 to a fx dx, that is, we got here fx. So this is a property which I have applied here, that is a minus x, okay, dx 0 to a. Okay, so this property we have applied because we know there it is. Now let us try to solve the second numerical using the properties. Now the second I have, that is sin x root sin x upon root sin x plus cos x. Okay, dx, the limit we have 0 to pi by 2. Okay, now let's try to apply the property. Now applying the property, I have 0 to pi by 2 sin pi by 2 minus x upon sin pi by 2 minus x plus cos pi by 2 minus x. Okay, so now let us try to solve this equation is numerical. Now what I will got here, this is, this will be I, first one. Now, and this I got cos x upon cos x plus sin x. Okay, 0 to pi by 2. This is I got second. Now adding first and second, we got sin x plus cos x upon we have sin x plus cos x under root. Now we got this dx, that is 0 to pi by 2. So I got what in this? Now we got dx. I got dx 0 to pi by 2. So I got x, that is pi by 2 0. Now here was 2I is equal to, so therefore I is equal to pi by 4. Okay, so that is how we evaluate definite integrals using particular property. Here I have applied the property. So this property I have applied, 0 to fx dx is equal to 0 to a f of a minus x. Okay, so we can solve numericals, that is we evaluate definite integral based on the property. So now let us try to solve next one. What we have now, let us see, we have the third question. We have third question we will try to solve. This is two numericals we have solved. Let us start third one now. Which property it will be applied? Let us see. So now the third question I have, that is the third question they have given is about this. Okay, so now I have got third one, 0 to pi by 2, we have sin 3 by 2 x dx upon I have sin 3 by 2 sin 3 by 2 x plus cos 3 by 2 x. So now this is a numerical we have, and we'll try to solve this, try to evaluate this definite integral based on this property. Now which property will apply? Let us see. 0 to pi by 2, we can write sin 3 by 2 pi by 2 minus x dx upon we have sin 3 by 2 pi by 2 minus x plus cos 3 by 2 pi by 2 minus x. Okay, now this is I, so I will got, this is first one and this is second one. Okay, now I got this. So now what will happen? 0 to pi by 2 sin 3 by 2, sorry, it will be cos 3 by 2 x dx upon cos 3 by 2 pi by, so I got a x plus sin 3 by 2x. Now if I see this, this is second, not this, this is the second. Now what we can do is add. We can adding first and second, we got adding first and second, what we got? 2I is equal to sin 3 by 2x plus cos 3 by 2x upon sin 3 by 2x plus cos 3 by 2x. So now if I use the identity here, what I got? 2I is equal to dx is equal to dx. So I got x here. So now I got pi by 2 0. I got 2I is equal to pi by 2. Therefore I is equal to pi by 4. Okay, so likewise we can easily solve numerical based on this. Now we'll try to solve next one. Three numericals we have solved. Now let us try to solve fourth one. Now the fourth numerical I have, now we'll try to see what is the fourth numerical we have here. We have the fourth numerical. Okay, so now we'll solve the fourth numerical, that is cos 5x. Cos is for 5x dx upon we have sin 5x plus cos 5x 0 to pi by 2. Okay, so now we'll try to solve this, how we can do it. Now we have, let us see how we can solve this numerical by applying the property I is equal to this much. This is first. Now I is equal to, we will use a property here, cos pi by 2 minus x dx, and here that is cos 5 pi by 2 minus x plus sine 5 pi by 2 minus x. Okay, so I got this pi by 2. So now I got sine 5x upon, I will got here sine 5x is for 5x plus cos is for 5x. Okay, so now we'll apply the property. After applying property, what I got, adding first and second, we got what we got here, that is 2i is equal to sine is for 5x plus cos is for 5x, we have dx upon, we have sine 5x plus cos 5x. Okay, so now I got 2i is equal to dx 0 to pi by 2, 0 to pi by 2. I got 2i is equal to x, pi by 2, 2i is equal to pi by 2, so therefore I is equal to pi by 4. Okay, so that is how we are able to evaluate definite integral using the properties. Here also I have applied the property, that is, that property what I have applied here is 0 to a f of a minus x dx. Okay, so this property I have used here. Now we'll try to solve the numerical now, fifth one. Okay, so you have the fifth numerical. Let us try to see how we evaluate the definite integral using properties. So we have this fifth one, minus 5 to 5, that is x plus 2. Okay, that is x plus 2 dx. So now we'll try to see how we can solve this. Now we know that two cases arises, that is one x plus 2 will be less than or equal to 0 when between minus 5 to minus 2. Okay, and it will be positive or equal to 0 when minus 2 to 5. So here now we have two limits, so we'll try to solve it out. Minus 5 to minus 2, that is x plus 2 minus, plus we have minus 2 to 5, it will be x plus 2 dx. Okay, so now I have applied the property that what I will say, that is fx is equal to a to b will have, that is a to c fx dx plus c to p. Okay, so that is how we try to apply the property. This is a property which I have used here. Now what we will do, let's integrate first. So I will get x square by 2 plus 2x, x square by 2 plus 2x. Now let us try to implement the limits, and here also we got the same, but here we have limits, that is 5 minus 2. Now let us apply. So I will get 4 upon 2 minus 4 minus 25 upon 2 minus, we have here plus we have, no, so it will be minus 10. Okay, minus 10 we have, and here we have negative sign, plus 25 by 4 plus 10. Okay, then we will apply minus, that is 4 upon 2 we have plus, so we will have negative 4. Okay, so that is how you can solve this. So now I got here, now here it will be plus, no, minus, no, minus 2 my negative. So now I will take the LCM first. So after taking the LCM, I got what? 4 to the 8. 4 minus 8, minus 4 upon 2 minus, I got here 25 upon 2. Okay, here I got 40, 65 upon 4 minus 4 to the 8 minus 4 upon 2, it will be 4 upon 2, that is 2. Okay, so finally I got my answer here, that is minus 4 minus 9 upon 2, that is 9 upon 2, plus we have 65 upon 4 plus we have 2. What will we do? We take the LCM 4, so 18 plus 65 plus 8. So I got what here? Which is 391 upon 4. Okay, so I got my answer here. Okay, so that is how we try to apply the properties to evaluate the definite integral. Now let us move to the next one. So here we have tried to solve the 5 numericals. Now we'll try to solve more using different definite integral properties. Now next question I have, so let us see how we can solve. Now the next question, that is we have x minus 5 to 8. We have different property will apply here. This is the 6th one. So we have 2 to 8 x minus 5 dx. Okay, now let us try to implement the property. Now let us try to solve this definite integral function. Now here we know x minus 5 will be negative or equal to 0, 2 to 5 we have, and it will be positive, or it will be positive 5 to 8. Okay, so now we'll apply the property here. 2 to 5, that is x minus 5, it will be negative, plus 5 to 8, so now we'll try to solve this. First we'll integrate square by 2 minus 5x, here the limit is 5 by 2 minus, plus here we have the limit, that is 8 upon 5, 8 5, sorry. Okay, so now let us try to solve this. We got 25 by 2, 5 by 2 minus 25. Then we have minus 4 upon 2. Okay, so let us try to solve it. Now try to solve. We'll here get what? Okay, we have applied 2 here now. 2 to the 4 by 2. Here minus 10 we have. Okay, so now I got this plus here 64 upon 2 minus 40. 64 upon 2 minus 40, and minus we have 25 upon 2 minus 25. Okay, so we got this. Now we can easily solve what we got here. 25 by 2 minus 25 minus 2 plus 10. Okay, now here also 32 minus 40 minus 25 upon 2 plus 25. So now what is left with us? We have minus sign, 25 upon 2. Now minus 27 plus 10 minus 17. Plus here also I got minus 8, 17. 17 minus 25 upon 2. If I now do this, minus 25 upon 2 plus 17 minus 25 upon 2. So what I got here is 34 minus we have, if we add these, so what I got 50 by 2, that's 25. So now I got my answer 70. Okay, so that is how we able to apply the property on evaluating definite integral. Now let us try to solve next one. Now let us try to solve one more to evaluate definite integral using the property. Now we have, let us see what we can do here. Let's see what we have the question here. That is the question we have. Now we will write the question first. The question is x is power 1 minus x की power n dx. Okay, 0 to 1. Now this question we have 7th one. So now let us try to solve this question using the property. So now what we can do here, first, therefore I is equal to 1 minus x, 1 minus x, okay, whole n dx. Okay, so now I got what here, 1 minus x, so it will be x over n. So now 0 to 1 dx. So now we'll have here xn minus xn plus 1. We have dx. First we need to integrate it. So now let us integrate. I got here n plus 1 minus x n plus 1 upon n plus 2. Okay, so likewise we can easily solve this. So now we have already done that. So now we need to apply the limits here. So I got here 1 upon n plus 1 minus 1 upon n plus 2. Okay, so I got this. Now n plus 2 minus n plus 1. I have n plus 1, n plus 2. So what I got here? Subtract it. Also we will get minus sign here. So we will get 1 upon n plus 1, n plus 2. Okay, so that is how we able to evaluate definite integral using the properties. Okay, so this. Now let us solve the next numerical, that is to evaluate definite integral based on properties. Now we have next question here, that is 0 to pi by 4 that is log 1 plus 10x with respect to dx. Here we'll apply the property. So now let us see which property we can apply here. That is log 1 plus 10, we have pi by 4 minus x. Okay, so now we'll apply this property. So now we'll try to solve this. Let us see how we can do it in a very easy way. We have log 1 plus, we'll apply the formula for 10a minus b. That is 10a minus b, 10a minus 10b upon, we have 10a plus 10b. Okay, so now we'll try to implement it. How to do it? So now what we got here is log 0 to pi by 4. Okay, we have 1 plus 1 minus 10x upon 1 plus 10x. Okay, so now what I got here, if I take the LCM here, 1 plus 10x plus 1 minus 10x, so we will have only 2, 1 plus 10x. Okay, so now let us try to see what we can do here. For log 2 dx minus 0 to pi by 4, we have log 1 plus 10x dx. So this is what we are solving, is I is equal to, so here I is equal to 0 to pi by 4 log of 2 dx minus I. So we got 2I is equal to x of log 2. Here I got pi by 4 0. So if I put the limit here, 2I is equal to pi by 4 log 2. So therefore I is equal to pi by 8 log 2. Because you know, if I put here 0 here, 0 into log 2, it will be 0. So that is how we able to evaluate definite integral using the properties. Okay, so now we'll try to solve more numericals based on definite integrals, that is to evaluate definite integrals using some properties. So now I have more numericals here. Let us try to solve. That is the question they have given. Now we will solve 9th question here. 0 to 2x 2 minus x dx. Here I will apply the property. Now let us see 2 minus x 2 minus x dx 0 to 2. Okay, so now what I got here, if I see 2 minus x and I open the bracket here, so I will get this dx 0 to 2, because here I have applied the property, that is 0 to a fx dx is equal to 0 to a f of a minus x dx. Okay, so this property I have used here. So now I will get 2 minus x root x dx 0 to 2. So now what I will get here, 2x for half minus x for half plus 1, that is 3 by 2 dx 0 to 2. Let us integrate. So now I got here 1 plus 2 into x 3 by 2 upon 3 by 2 minus x 5 by 2 upon 5 upon 2. So now I got is 0. Now the next thing we'll have, that is 4 upon 3 x is power 3 by 2 minus 2 upon 5 x is power 5 upon 2 0. Now if I put the value, I got 4 upon 3 2 raised power 3 by 2 minus 2 upon 5, 2 raised power 5 upon 2 minus 0 it will be. So this is my answer. Okay, so I got this answer. Okay, so that is how we can evaluate definite integral using different properties. Now let us move to the next question we have. So now the next question we'll try to solve. Let us see that 10th numerical. We have solved 9 numericals based on these. Now we'll move to the next numerical. Okay, so now let's try to solve this one. 10th numerical I have, that is what I have here, x minus 1 dx 0 to 4. Okay, so now I have, that is what we need to apply is, what we know, x minus 1 will be less than equal to negative at 0 to 2. Okay, or I can say 0 to 1 we have taken now. And from 1 to 4 it will be x minus 1 will be greater than or equal to 0. Okay, if I put 1, 0, 2, if I put 3, 4, it will be positive. So we can take this value here, 0 to, this will take 1. So we have x minus 1 minus dx plus 1 to 4. 1 to 4 will have positive value here. Okay, so now let's try to solve this. We got x square by 2 minus x. Okay, now here the value, and here x square by 2 minus x. So now we have 4, 1. We have 1 by 2 minus 1 minus, if I put 0 it will be 0, plus here also 4 square 16 upon 2 minus 4 minus half minus 1. Okay, so that is why how we can solve half minus 1 minus half, half plus 8 minus 4, 4 minus half minus 1 minus half, it will be plus half. So what I got here, half plus 9 by 2, we got 10 by 2, that is 5. Okay, so that is how we able to evaluate definite integrals using the following properties. Now we'll try to solve the another definite integral. Okay, so now let us see what they have given in this. The next question we have 0 to pi. Okay, 11th question now I am solving. 0 to pi x dx upon 1 plus sine x. Okay, so now what we can do here, directly put the property here, pi minus x dx 0 to pi upon 1 plus sine pi minus x. Okay, so I got pi minus x dx upon, let this, it will be I. So now pi minus will be sine x. Okay, so now 0 to pi, this is second, this is first. Now what we'll do, adding first and second, we get, what we get here, if I add both, so I will get here x plus pi minus x upon 1 plus sine x, 0 to pi dx. What will happen, I have got pi outside, now I got 1 plus sine x. Okay, 0 to pi. So now what we can do here, now let us try, we can take, we can do the rationalize. Okay, so I got 1 plus sine x, 1 minus sine x. Okay, so that is how we can easily rationalize. We have taken pi outside because pi is a constant term. Now what will happen, 1 minus sine x upon 1 minus sine square x 0 to pi dx. So what will now happen? Cos square x. 1 minus sine square x is equal to cos square x. So I got 1 minus sine x upon cos square x dx pi. Okay, so now I can separate them. 1 upon cos square x will be sec square x and will separate out. So what I will got here? Minus sin x upon cos x, tan x, sec x. 0 to pi dx. Okay, so now finally what I got here, integration of sec square x will be tan x. So I got here tan x pi 0 minus tan x will be sec x pi 0. So now we'll try to sort it out. Now we know 0, okay, 0 minus 0 it will be 0 because we know tan pi will be 0 and tan 0 will also be 0. Now sec 180. If I calculate sec 180, so I will get sec 180 will be 1 and sec 0, that is 1 upon cos 0. So cos 0 is 1. So 1 plus 1, it will be 2. Okay, so I got 2 here. Okay, so now I got 2 pi. Here we have taken the 1 plus 1, 2i. Here, no? So now what I got here, 2i is equal to, so therefore I is equal to pi. Okay, so that is how we able to solve. 2 pi we have, so 2 will be cancelled, so it will be only pi will be. Okay, so that is how we able to evaluate the definite integral using following properties. Now let us try to solve more numericals. Now I will try to solve the 12th one. Okay, so now 12th question, let us see how I able to solve. So now let us see, I have in my hand, that is a 12th question, that is 0 to a root x upon, we have root x plus a minus x dx. Okay, so now let's try to solve it by using the property. It will be a minus x root, this is first one, I is equal to, and upon here root x plus, no root x, no, we'll root a minus x plus, if I put here a minus x, so it will be x only. Okay, so a, so this is second. Now if I try to add, what will happen? Adding first and second, what will get? 2i is equal to root x plus a minus x upon a minus x plus root x. Same we have here. Okay, 0 to a, what will happen? I've got 1 only, that is x. So now 2i is equal to x we have, and here we have a 0, so I got 2i is equal to a, therefore I is equal to a upon 2. Okay, so likewise we can able to solve definite integral using following properties. Now let us try to solve more numericals. Now we have solved 12 numericals. Now let us try 5 to 6 numericals more. Okay, so now let us see, we have solved this. Now let us try to solve more numericals here. Now let's try to solve this one. Okay, this one we'll try. This is what we have, this question 13th, that is 0 to pi by 2. We have 2 log sin x minus log sine 2x dx. Okay, so without solving, let us try to see 2 log sine x 0 to pi by 2. So minus, we can write log sine 2x will be 2 sine x cos x. Okay, so we have this, and now we'll try to solve. What will happen? 2 log sine x, okay, 0 to pi by 2. We have minus, we know log AB we can get log A plus log B, but we have minus sign outside, so we'll multiply. We'll get here log sine x minus log cos x minus log 2. Okay, so now what I got here, 2 log sine x minus log sine x, we'll have log sine x minus log cos x minus log 2. Okay, 0 to pi by 2. This is I got second, this is what first. Let I is equal to this much. Now what we will do? Adding, we'll adding first and second, or what we can do now, this is what I got I. If I say this now, no need to add first. Now what we'll do, we'll try to put the value here. So I will got log, now this is my first one. Okay, so I got log pi by 2 minus x cos x, log pi by 2 log sin x, and minus log 2. Okay, so this is become second for us. Okay, 2 pi by 2. So now we'll try to put the value, adding first and second, adding first and second. Now we got here what to do when we add. So what we left, this they will be reduced, we'll get minus 2 log 2, 0 to pi by 2 dx, and where you have 2i. So what will happen? I can write 2i is equal to minus 2 log 2 0 to pi by 2 dx. So I is equal to log 2 will be outside, and we have x here, 1 integration 0 to pi by 2 x, we have dx. So we will have x minus log 2 x. If I put here pi by 2 0, so I will got minus log 2 pi by 2, or else I can write pi by 2 log 1 upon 2. Okay, so that is how we able to solve the numerical. Now let us try to solve next numerical. We have solved 13 numericals, that is we have evaluated 13 definite integral functions using the properties. Now we'll move to the 14th one. Now we have the 14th question here. So what is the 14th question we have? I have in my hand, that is sin x minus cos x upon 1 plus sin x cos x dx upon 0 to pi by 2. Okay, so now let us try how to solve this. We'll put the value here, sin pi by 2 minus x minus cos pi by 2 minus x upon 1 plus sin pi by 2 minus x cos pi by 2 minus x with respect to dx 0 to pi by 2. So this is first one. I is equal to, this is, I'll got here cos x minus sin x upon 1 plus sin x cos x, okay, dx. So now what will happen? Let it be 2. What will happen now? Let's add. Adding first and second, we get, so what will get here? Very simple. Sin x minus cos x plus cos x minus sin x upon 1 plus sin x cos x. Okay, so I got 0 to by 2 dx is equal to 0. Okay, so that is how we evaluate different integral using the following property. Here I have used that property. We all know that is 0 to a fx dx is equal to 0 to a f of a minus x dx. Okay, so this property I have used. Now let us evaluate another definite integral. Now let us try to evaluate next definite integral. Okay, so now we'll try to sort it out. Evaluate 15th question now. I have the 15th question, that is minus pi by 2 to pi by 2 sin square x dx. Since we have this in a very easy way, that is, we all know sin x square. Okay, we can take minus x whole square will be sin square x, that is positive function. So we can write 0 to a fx dx twice. Okay, so this is the property which I am using. If it is positive, then it will be even function. Okay, so now it's an even function because it is positive. Now we will try to use this 0 to a. We'll write sin square x dx. So we all know we can write, we have a here. What is a here? Pi by 2. Okay, pi by 2. So I will write here pi by 2. So sin square pi by 2 minus x dx. So I will got 2 cos square x dx. This is the second one. Okay, and this is the first one. Now adding first and second. Adding first and second, what we will got here? Now where we will got here, that is sin square x plus cos square x dx. 2i is equal to, so what will get? 2i is equal to 2 dx. So now I have got I is equal to x, and here is a value pi by 2 0. So I got pi by 2. Okay, so that is how we able to evaluate the definite integral using the properties. Now let us try to evaluate another definite integral. Now we'll try to solve the 16th one. So now we have the 16th. Now the 16th question we have, that is minus pi by 2 to pi by 2, we have sin 7x dx. So now very easy question we have. We all know that is sin 7 minus x minus pi by 2 will be negative function sin 7x dx minus pi by 2. So we can say it will be 0 since f(x) is an odd function. Odd function, so it will be negative. That is how we will to evaluate the definite integral. Now let us try to solve the next one. Now let us try to evaluate another definite integral using properties. This is my second. So the question is log 1 plus cos x dx. I have this question 0 to pi. Okay, so now let us try to solve this using the properties. So now log 1 plus cos x, I can directly write here, that is pi minus x dx 0 to pi, it will be log 1 minus cos x. Okay, 0 to pi dx, this is second one, and I, this is first one. Now adding first and second, we get 2I is equal to 0 to pi log 1 plus cos x plus log 1 minus cos x. So log A plus log B. I can clearly write log AB. So we'll got log 1 plus cos x 1 minus cos x dx. So what I will got here? Log 1 minus sin square x. Log 1 minus sin square x dx 0 to pi. Okay, so now I got 1 plus cos x into 1 minus cos x is 1 minus cos square x. So next step will be log 1 minus cos square x will be sin square x 0 to pi. Okay, so now we'll have 2 log sin x. If I take this here, so I'll got 2I is equal to 2 log sin x dx 0 to pi. So now I got I is equal to log sin x. We'll log, we have log sin x dx pi to 0. Okay, after getting this, now I am getting this value here, that is log sin x. Okay, wait. Now what will happen? We all know that log sin pi minus x will be sin x. Okay, so it's a positive function, so we'll take as twice of 0 to pi by 2. Okay, we'll take as this. So we'll have log sin x dx. Now what we'll do? Let us try to solve it out further. Now after solving, what I will get here, that is 2 0 to pi by 2 log sin pi by 2 minus x dx. It will be 2 log sin, it will be cos x. Okay, 0 to pi by 2 dx. Now take this A and B, adding what we get twice of log sin x plus log cos x dx. Now what will happen? We'll take 2 outside. 2I is equal to 2. So it will be, we can do this, log sin x plus log cos x plus log 2 minus log 2 we have done here, so that we can easily sort it out this numerical. Now let us try to do it on the upper side. So now what will happen here, it will be, we have log 2 sin x cos x, we all know log a plus log b will be log a b, so this, and we got minus log 2 dx. Okay, 0 to pi by 2. So likewise we have log sin 2x minus log 2 dx. If I take this pi by 2 and here I have 0 to pi by 2. Okay, so likewise we can solve, we can evaluate definite integral using this. Now what we can do further, now we know we can integrate, that is log x is equal to 1 upon sin 1 upon x, and sin 2x integration will be minus cos 2x. So we'll get minus cot 2x by 2 we can take outside, 0 to, so we have done this. Okay, so now what will be, 1 by 2 will be outside, here it will be pi by 2 0. Okay, because cos 2x, so cos 2x upon sin 2x cot 2x and 2x, so it will be like this. Now minus log 2, here we have x, so now I can put the value here so that I can got my answer, that is pi by 2. So cot pi, cot 180 still, but still we have answer will be here. If I say 0, yes, it will be, our answer will be 0 minus, so we have 2 log pi by 2. Okay, so that is, we got my answer here, minus 2 log pi by 2. So that is how we able to evaluate the, no, you can easily evaluate that value. Okay, so no, 2 will be inside, no, so 2 pi by 2 log pi I have. Okay, so I have pi, left it minus log pi. Okay, so that is how we able to evaluate definite integral using the different kind of properties. Now let us try to evaluate one more definite integral using properties. Now let us try to evaluate one more definite integral, that is, we have 0 to pi by 2, we have pi, we have here 2 pi, and we have cos 5 raised power dx. So now we all know, that is, cos 2 pi minus x will be cos x. So it is positive, it is an even function, so we can write here twice of 0 to pi, so it will be that the function will be cos 5x dx. Okay, this property I have applied here, this is the property which I have used, that is for the 0 to 2a, that is 2a minus x will be fx, so we will write 0 to a. Okay, so now we can use pi here, so we can easily solve the integral using the property here. Okay, so now I hope it's clear now to everyone, and able to connect with me that how we can evaluate definite integral using different properties. If you have any doubt, you can ask, you can share. Okay, share my channel, if comment if you have any doubts, and you also like my channel. So thank you.